Now, I'm super excited to introduce you to 2 times world champion and Olympic medalist, Denise Schindler, who's going to come up and talk about her personal experience. Because I think that's, again, I'll go back to the fact that we often miss the fact that the most important thing about this whole process is the people that it affects and the types of applications that they find for this technology. And I think you're going to find the next application super interesting and very compelling. So thanks for your time. I hope you enjoy the 2 days, and I'll look forward to speaking to you more.
Yeah, good morning, Toronto. I hope every one of you has enjoyed a good cup of coffee, a good cup of tea so far. I'm very excited to be here today. I want to share my story of how 3D software, 3D printing has helped me and supported me in winning 2 medals at the Paralympic Games in Rio. So shortly, maybe not everyone knows you or knows me, sorry. I would like to introduce myself. I'm Denise Schindler. I'm a professional cyclist now since 7 years. Still not retired, so still cycling and active. And I'm riding for the German team. In the meanwhile, I collected some kind of medals. To highlight my best results are 3 Paralympic medals. I am been 2 times world champion and added 1 title this year. I'm the current world champion on the track. So I'm still busy with cycling, and you can watch out. Next goal is Tokyo 2020. But what's so special? Well, you can see it right away as I'm standing here with a skirt. I'm a Paralympic athlete, and you may wonder now what happened. Why do I have a prosthesis? So when I was 2 years old, it was during winter, it was very icy. I slipped and I hit the train. You can imagine, hitting a train is not the best idea. So, well, I won against the train, but they had to amputate my right leg. So my lower leg got amputated. They were able to save my left leg, which I still have a stiff ankle and some injuries, but it's fine. I make it some way. And since then, I walk through life with my prosthesis that enables me to walk through life very easy. I'm a woman, and a woman needs a lot of shoes. Well, in my case, a lot of prosthesis. But obviously, I have a problem. I can't go on Zalando and just order my shoes and buy them there online. So what I have to do, and you can see it right in the picture, I have to go to my orthopedic technician and ask him to do me a new shoe, which is a new prosthesis. So why do I need different kind of prosthesis? You see me right here with my normal walking prosthesis, which is for everyday life. It's covered by insurance. But if I want to go cycling, if I want to go into the water, go swimming, I need a different kind of prosthesis, which is just made for that specific need. So I'm asking him to do that. My orthopedic technician is 60 years now. So you can imagine that he has a huge knowledge and huge amount of experience. And he's doing my prosthesis since over 25 years now. So I'm not the youngest anymore, but still fine. So with his huge knowledge, we've been able really to create good prostheses which are fitting. And this is the basement. If I don't have a prosthesis that is fitting 100%, I wouldn't be able to stay on that stage and walk like that and smile. Because if I have a prosthesis that's not fitting 100%, it causes pain, it causes problem. I'm not able to walk properly. How is it done? The traditional way of making prosthesis is a very hands-on way. So he starts doing that, he's doing it with love, and it's a 100% individual thing that he's doing. It's just made for me. The socket has to be 100% specified for me. And he's doing that in his workshop, hands-on. So it means he basically starts with a plaster cast. With the Plasticad, he's able to work and move on and to make myself a testing socket. So I get a testing socket, and with the testing socket, as soon as I have it, I use it for at least 3 weeks, and I give him continuously feedback, and we make changes on it. So he has like a kind of industrial hairdryer, not a normal one. And then he's been able to adjust the socket all the time until I say, it takes about 1 month, until I say, okay, that socket is 100% fine, I don't have any pain anymore, no pressure points. And then he's doing me my final one, which is made out of carbon. You can hear that it's a kind of old and traditional, maybe old-fashioned way to do and to manufacture prostheses. So in 2014, I talked to Autodesk, and we wanted a bit to change that, and had this vision and new idea of making prostheses in a different way. So how did we start? Yeah, we just basically scanned my limb. So you see Mickey Wakefield, very popular guy, I know him pretty good, laying on the ground trying to scan my limb. So it's a very easy first step, and you may wonder, yeah, scanning a limb, what's so special about it? But imagine going back to the workshop. Before, I was just a plaster cast, you know? There was no 3D scan of me available. So now, for the very first time, I became a 3D patient with available data, available anytime, anywhere. And for the first time, I was in the software. So they were able, with the scan of my limb, now to have me in there and to start in the software, Fusion 360, to combine organic forms with the needs of mechanical engineering. So what was the problem all the time before? The softwares, when I would be there in there as a 3D scan, and my orthopedic technician would start working on that model, he would like produce sharp edges. And that's a big, big problem and big point. The orthopedic technician must have a software where he can use and change and adjust areas in a very soft, organic way. Because otherwise, as soon as I have in the socket a sharp edge or something that is not 100% smooth, it causes me inflammations, for sure. So this precise modulation that he's doing with that 3D scan and the model to make a testing socket is the basement of a prosthesis that's working and that enables me to work without pain. So that's fitting 100%. So you have to know, if he takes my scan of my limb and takes a 100% negative and makes a testing socket, that would be the worst he could ever do. He has to define areas on my limb which are able to carry my weight, and as well he has to reduce the pressure on points which are very bony or at the very end of the limb. If there is pressure on, that's not a good idea. Yeah, you can see there have been a lot of people working on it. So on the project, and this is something really which is a breakthrough, it was the very first time that we had now a cloud-based software, and everybody and everyone could work in the project from everywhere. Before, remember again, we would have all been a must that we've been in that workshop to produce it in the old manufacturing. But now we had a cloud-based software, and everyone could work on that. So who was involved? You see the crazy guys on the left and the right. You recognize right away Paul Sorhi. Your side would be the left. Yeah, Fusion 360 evangelist. At that time based in London, meanwhile moved to Boston, but basically around all over the world, and not locally at one place very long. On the right side, you can see me, a crazy athlete who is traveling as well all over the world. enjoying training camps on the sunny side. So I'm staying in Spain, I'm staying in South Africa, I'm staying in Switzerland. So wherever the weather is fine and there are nice hills and climbs, I am there. But as well, I'm traveling a lot for my races for sure. So I will be in Japan, I will be in America, in Canada. So I'm really traveling a lot. So to me, one thing in that process of making prosthesis a new way, I really wanted to have change what that I don't have to be there all the time locally, because my time is really limited. I need the time training. So for me, it was really good that now I was able to give feedback via phone, via cloud, working on the project, via mail, which before would have not been an option. In the middle, you can see my prosthesis expert with his son. This is Thomas and Felix Wellmer, and two guys from the Autodesk team in Munich, especially Mickey Waverfield, who likes to scan my limb. But there were more people involved, as you can see here on this picture. We had also an institution in Berlin involved who specialized in aerodynamic optimization. So they helped us getting a cycling leg for me. Well, I wanted to compete, at the Paralympic Games, not just climbing some kind of mountain. So this cycling leg as well had to be very aerodynamic. We also involved experts who ensured that we have the perfect power transmission in the leg, in the prosthesis. So there were a lot of other people involved from all over the world. And if we wouldn't have had the project on that software, cloud-based, that would have not been possible. What is also a breakthrough, for the first time, I'm not a blaster cast in the workshop, and we have available data. And really, for orthopedic technicians and prosthesis experts, this will be a breakthrough, because with more and more data coming in of scanned limbs and of sockets they are making, and the feedback if that socket did work or not, or what specialties the patient had on his limb, or what kind of physical health he was, we can collect the data and ensure in the future a better fitting for the prosthesis. Example, just that he could use some kind of filters just made for the making of prosthesis and the making of test sockets. At the moment, this is not available. So it all depends on the orthopedic technician whether he is doing it 100% good or not. As well, for the first time, we have a transfer know-how. So in the past, and still now, most of them just doing it in their workshop, and all the knowledge is locally in the workshop with that orthopedic technicians. They're not able to share easily a socket or the way he did produce that. To share that, they have to come to that workshop locally. And my workshop for my orthopedic technician is somewhere in Bavaria on the countryside. So you fly to Munich, and then you have to drive with your car 2 hours, and then you're there. So, not that easy. With having projects and all the scans, the sockets now as data in the software, it's so easy to share and to share knowledge, and that would make a big step in making better prosthesis. Yeah, when you have the file, and for Paul and me, well, for all of us, it took really a long time until we had I think Paul told me one time that it took him 60 drafts until we had a version that we've been able to print. So it's not that easy, but what is amazing about going back and forward all the time, before, you were not able to do a lot of different kind of versions without producing it, because you can't draft whatever you like. You have to produce it in the old way of manufacturing it. Now we've been able to go back and forward all the time. So when I had the first testing socket, I gave a lot of feedback, and Paul thought, okay, awesome, I'm gonna update it, and then we're done, and Denise has a cycling lad. Don't mess with a professional athlete. He always thought he's done, and I picked up the phone. Oh, Paul, I got a good idea, that aerodynamic, and then we can do that. And for the starting, I think it's better if we change that and that. And he was like, okay. So we had a lot of back and forward in the draft, but that made it really a good leg in the end. And as soon as we had it, we sent that file to the printer and printed it. Super easy, huh? So why did it take us 1.5 years to do it? No, I'm just kidding. But everyone can imagine that it's not that easy, and it's really challenging to have a performing prosthesis for Paralympic Games. So it has to be 100%. So if we mess it up, you have the chance every 4 years. So we had no chance to mess it up. We had to do it 110%. This is how the prosthesis looked like in the very end. So you can see it's very thin. The form is very fine. It is aerodynamically side optimized. And you may wonder now, where's the foot at the end? I don't need it. It's a cycling prosthesis, and for me, it's really just a sports tool. So with that sports tool, before I go on my bike, I put it on. I click into the pedal right away, because at the end there's a cleat, and I'm cycling. And I go off the bike and just change my legs. The only thing, when I have to get off the bike in between is like when I do an endurance ride for 5-6 hours, somewhere in Spain when it's warm and sunny. And then I go for a cup of coffee after 2-3 hours. I get off the bike, walking like Captain Hook to the coffee shop, ordering my coffee. May look a bit funny, but that's okay. So it's more like high heels walking. But this is really a sports tool. It's just made for cycling, for performing, not for walking. In 2016, right before the Paralympic Games started, we had really the honor to show and present our project, these two guys. I think the blue fits perfectly to my jersey, huh? Obviously, Angela Merkel, the German Chancellor, and Barack Obama, who have been at Hannover Messe, which is a big fair there. It was a really nice conversation with both of them, and it was a really honor to introduce their project to both of them. Especially Barack Obama impressed me pretty much, because he's a man who's really interested in sports and very open to that. And when we've been highlighting the benefits, he recognized right away, okay, there's one hand, this is like me as a professional athlete having a performance prosthesis. But it's much a wider perspective. It's not only about me being a Paralympic athlete who wants a prosthesis, that it has a wider perspective for an average amputated person. Why? If you're an amputated person and you have a sports prosthesis, you can walk again, you can cycle again, you can go running again, you can go climbing again. That's just amazing. And if we have a new way of making the prosthesis, which make prosthesis more affordable for everyone, this is really a changer, because then someone can just buy his sports prosthesis. And at the moment, they are so expensive. This is a small car that's just up there, or here, down there. So it's too expensive just to buy one. So just been talking about the benefits. It's about minimizing the production time for the orthopedic technician. This is one big thing. So you have to know as well that an orthopedic technician, he's starting with the plaster cast, okay? Then he's doing the testing socket. He is involved all the time. So there's no one point in the chain, no point in the chain, that he has time on the next patient. So from the process, starting from the plastic cast, producing the testing socket, adjusting it to me, and then again making the final socket with carbon, it's always him in person who is doing that. Now with that, he is doing the scan, he's doing the precise modulation on the 3D model, and then he's sending that file to the 3D printer, and that guy is doing the job, which is awesome. Because now the prosthesis expert has more time on the next patient and can reduce his costs. And every one of you knows that health insurances are cutting down tremendously budgets. So they're really struggling to fundraise themselves and that it's still in balance. So this is a good chance for them to have now more time on the patient and more time for quality and not quantity. Another point is that with the printing, we can combine new materials and have new structures, new thickness of materials. So my vision is that through the 3D printing, we are able to use softer spots inside. So you have to know outside it's very needed that it's stiff outside. But inside, we always have the problems that we need sometimes softer spots to reduce pressure marks. And with new materials and printing coming up, new structures, new thicknesses that we can use and combine new materials, we really have a chance in future to reduce pressure marks. What else is important or was a benefit in producing? We could increase the aerodynamic stuff. So you all will have seen a cyclist, or? If you've seen us on a time trial bike, we look very fancy with this aerodynamic helmets and this lycra wear and our bikes. Looks a bit strange sometimes, like an alien, but it's all for aerodynamic reason. It makes us faster, and fast is always good because then we are faster at the finish line, the suffer is faster done, and maybe we collect a medal. So we also had really to keep an eye on the aerodynamic stuff on the prosthesis. And just to give you some insights, I did testing with the old version of my prosthesis before and the optimized version I used at the Paralympic Games in Rio. Testing it in the velodrome at 3 kilometers, which is my pursuit, I saved almost 2 seconds, which is a lot, you know? And you can imagine if I save 2 seconds at 3 kilometers, my time trial, and I don't want to miss that picture, where I won a silver medal, was 20 kilometers. So 2 seconds at 3 kilometers, summing up to 20 kilometers, is a good summary, I guess. So it really supported me in supported me in winning the medals. So, of course, I have to be in 100% shape. But as a cyclist, it's always the combination of a perfect trained athlete and perfect equipment that fits together, as well as the prosthesis. So I'm very proud to share that I've been able to collect 2 medals at the Paralympic Games, which I'm very proud of, a silver and bronze medal. And thanks Autodesk, you've been one big part, so thank you for that. But I also want to open up your mind a bit and give you a different kind of perspective. For sure, it's nice if a Paralympic athlete who is training every day and has that dream of winning a medal at the Paralympic Games is winning 1 or 2. But there is a wider perspective. What is disability at the very end about? For us, as I told you in the beginning, prostheses are like shoes. So if we have a shoe that enables us again to do sport, we are back. You know, we are not disabled in that kind. To give you an example, like if you would go running now with your nice business shoes and would like in the morning to do a short run of 10K, short. what would happen? It would cause pain, you would get blisters, it would not work. Well, I guess so. It's the same for us. If I take my normal walking prosthesis and I would like to go cycling with that as I do, that wouldn't work. That would really cause a big problems, pain, issues. I wouldn't be able to do that. Last year, I fulfilled one of my biggest dreams. I did the Tour Transalp. So you may wonder, if you're not a cyclist, what is the Tour Transalp? It's a 7-stage race through the Alps. So 7 days just climbing uphill, downhill, uphill, downhill. There's basically no flats. In total, it's more than 850 kilometers, which is not the problem. The problems are the height meters. It's 18,000 height meters. And that's a lot. And really, I've been suffering a lot as well. But I've been the very first woman amputated who ever did that and made it to the finish line after 7 days of racing. This would never have been possible with a normal, regular, walking, daily life prosthesis. And that's what I like to share with you and open up your mind for. You're just disabled if you're not able to do something, right? But if you have a tool that enables you again, for me, a prosthesis, then, sorry guys, I'm not disabled anymore. I'm with you, I'm not excluded. And that is what it's about. If I have a tool that brings me back to life and gives me back the life I had before, you know, I'm happy. I don't miss anything. I can pursue my dreams. And for me, in my heart, something I really wanted to change are the kids. If you as a kid have sports prostheses that enable you again to run, that enable you again to play soccer, then you win again, you're not out, you feel confident, you learn to trust in yourself, and you smile and run. And this is something I would like to encourage you. Help us on that way that we open up this world again for kids and for people who are amputated, that they're in again and that they are smiling and they are taking life as it is, and then they're able to run, to cycle, to climbing, whatever they want. And that we all together create a better world. Thank you.